All right, class, this week's lab is the heat of fusion for water. Heat of fusion is a physical trait or physical property. Okay, it's got a certain value for water. I'm not going to tell you what it is because we're going to discover it and then see how close we get. All right, but basically it's how many calories per gram, how much energy per gram, okay, to take water from a solid state to a liquid state. Okay, so from being melting ice basically. Okay, so if you look at a phase change graph, okay, if we take water, we heat up water, we start down here at negatives, let's say that's like negative 20 degrees or so. Okay, it's going to be ice, and as you heat it up, okay, molecules move faster and faster until you get to zero. And then something bizarre happens, it flattens out like that, okay, which means all that energy is being used to change it from being a solid into a liquid. Okay, that's called the heat of fusion. Okay, so we're going to figure that out today. Of course, when it gets to 0 degrees and it's all melted, then you heat it up. Okay, and the temperature gets higher, higher, and higher. You're in the liquid state here. When you get up to 100 degrees, okay, then you get another flattening out. Okay, and then that's changing it from being a liquid into a gas. Okay, so the temperature will stay at 100 degrees until you get all to a gas, and then if you heat up a gas, of course, it can go up higher and higher. All right, so that's a phase change graph over time. All right, so to figure this out, we got to figure out how much energy it takes to melt ice. Okay, so here I've got some hot water. I'm going to pour about 100 milliliters into this Pyrex bowl, a little more than 100. Okay, but I'm going to get it specifically or accurately. Okay, so normally you don't pour over a balance, but for your sake I will. I'm going to get it right to 100. Okay, measure exactly. If I had a graduated cylinder, I could use that because here's right at 100. Okay, and I'm going to pour it. I warmed this up a little bit so it wouldn't lose heat to that. I'm going to pour it into this calorimeter, and I'll nestle this to make it even better. And of course, Mr. Ford will appreciate that because he loves the ducks. Okay, now I need to take the temperature. All right, so I've got the thermometer in here getting the temperature. Okay, I can wait till that equilibrates. Okay, so far we got 100 grams of water, which I put in there. Okay, we know the specific heat of water is 1 calorie per gram degree Celsius. Okay, that's a value. Hopefully you remember that concept. And then we'll get the starting temperature in a moment. And I got ice here, okay, which we're going to melt. All right, so I think we are ready to go. We take this out. One moment. And it is right now at 66 degrees. All right. So I'm going to pour the ice in here. Okay. And of course that warm water should melt the ice. Okay. Let that melt here a little bit. So the starting temp was 66 degrees Celsius. Of course, the temperature is going down, so the heat from the hot water is being used to melt that ice. So we're going to determine how much heat was lost. It's important that I actually keep a little bit of ice in there until it's still a little bit of ice. Of course, you could get some heat lost. I can feel it getting hot, so it's not going to be perfect. Okay, but it is all melted right now, and the temperature is at 29 degrees. 29 degrees Celsius. All right, so I can temp there. 29 degrees Celsius. Okay. So what we want to know, of course, is the change in temperature. It went from 66 to 29. So I believe that is 37 degrees. So make sure 7, 5, yep, 37 degrees Celsius. Okay, now we got to figure out how much ice was melted, because with this now we can figure out how much energy. So we take 100 grams times 1 calorie per gram degrees Celsius times 37 degrees. Yeah, that happens to be body temperature of human beings. That's your body temperature. All right, now I want to figure out how much ice melted. Okay, so I'm going to take my cup, place it on here, hit the tare. Okay, so now that's part of the balance. And I'll take the water that I started with 100 grams plus the ice that I melted. I'll pour it in here. Okay, and let's see what we get. Okay, 143.21. I'll round that off to 143.2 grams. But now, let's look at this. Okay, we started with 100 grams. We ended up with 143. So the actual amount of ice melted, I'll take away 100. So it comes out to be 43.2 grams of ice melted. Okay. So with that, now we should be able to figure out what the heat of fusion of water is. All right. So hopefully we'll get a true value or close value.